problem, we are analysing a function involving absolute values. The function is the absolute value of 3x plus k minus the absolute value of 3x minus k. To solve this, we begin by identifying where each expression inside the absolute value becomes 0. These are the points that divide the number line into separate intervals. Let's first assume that k is greater than 0. The expression 3x plus k becomes 0 when x is negative, k divided by 3. The expression 3x minus k becomes 0 when x is positive, k divided by 3. So the number line is split into 3 regions. 1. X is less than negative k over 3. 2. X is between negative k over 3 and k over 3. And 3. X is greater than k over 3. Now let's understand how each absolute value behaves in these regions. Let's define A as 3x plus k and B as 3x minus k. For when x is less than negative k over 3, a is negative, so the absolute value of a becomes negative a. For all other values of x, a is positive, so the absolute value of a is simply a. For b, when x is less than k over 3, b is negative, so the absolute value of b becomes negative b. When x is greater than k over 3, b is positive, so the absolute value of b is just b. We now analyse the expression, the absolute value of a minus the absolute value of b. First interval, x is less than negative k over 3. In this region, both a and b are negative, so the absolute value of a is negative a and the absolute value of b is negative b. The function becomes negative a minus negative b. This simplifies to negative a plus b, substituting in the expressions for a and b negative 3x minus k plus 3x minus k. The 3x terms cancel out and we are left with negative 2k. So in this region the function is constant and f of x equals negative 2k. Second interval, x is between negative k over 3 and k over 3. Here a is positive and b is still negative. So the absolute value of a is a and the absolute value of b is negative b. The function becomes a minus negative b, which simplifies to a plus b. Substituting again, 3x plus k plus 3x minus k. The k terms cancel out, and we are left with 6x. So in this region, f of x equals 6x. Third interval, x is greater than k over 3. Now, both a and b are positive, so the function becomes a minus b. Substituting 3x plus k minus 3x minus k, the 3x terms cancel out and we get 2k. So in this region, the function is constant and equals 2k. Let's now summarize the overall behavior of the function. In the first interval, where x is less than negative k over 3, the function is constant and equals negative 2k. In the second interval, between negative k over 3 and k over 3, the function is linear and equals 6x. In the third interval, where x is greater than k over 3, the function is again constant and equals 2k. We are told that the difference between the maximum and minimum values of the function is 10. That means 2k minus negative 2k equals 4k. So 4k equals 10, and solving for k, we get k equals 5 over 2. Now let's consider the case where k is less than 0. In this case, when the sign of k is flipped, the graph becomes a reflection over the x-axis. Since k is less than 0, the maximum value becomes negative 2k, and the minimum value becomes 2k. But let's still go through the process carefully, step by step. To make it easier, let's define t as negative k. Then t is a positive number. The function now becomes the absolute value of 3x minus t minus the absolute value of 3x plus t. Let it equal 3x minus t and b equal 3x plus t. The expression a becomes 0 when x equals t over 3. The expression b becomes 0 when x equals negative t over 3. So again, we divide the number line into 3 regions. First interval, x is less than negative t over 3. Here, both a and b are negative, so the absolute value of a is negative a and the absolute value of b is negative b. The function becomes negative a minus negative b, which simplifies to negative a plus b. Substituting negative 3x plus t plus 3x plus t. The 3x terms cancel, and we are left with 2t. So in this region, the function equals 2t. Second interval, x is between negative t over 3 and t over 3. Here, a is negative and b is positive. So the function becomes negative a minus b, substituting negative 3x plus t minus 3x minus t. Simplifying, we get negative 6x. Third interval, x is greater than t over 3. Now, both a and b are positive. So the function becomes a minus b, substituting 3x minus t minus 3x plus t. Simplifying, this gives negative 2t. Let's summarize this case. For x less than negative t over 3, the function equals 2t. Between negative t over 3 and t over 3, the function equals negative 6x. For x greater than t over 3, the function equals negative 2t. Once again, the difference between the maximum and minimum values is 10. So 2t minus negative 2t equals 40, which means 40 equals 10 and t equals 5 over 2. Since t is negative k, this gives us k equals negative 5 over 2. Final answer, k equals positive or negative 5 over 2.